Hello, welcome. Today we're going to be looking at network analysis. In network analysis, we look at a network. Then we determine the longest route to completing a task or the shortest route to completing a task. We also look at the network and we determine the costlier route to completing a task as well as the less costly route to completing a task. So a network is just the connection of processes in chemical engineering or connection of activities. So when these activities are connected, we check out what is the longest way to get into our aims, or what is the shortest way, or what is the costlier way of getting to our aim. So this is what is depicted here. We have two factories, F1 and F2, that needs to produce something, and they need to get it to warehouses, W1 and W2. There are several ways of getting what is produced here to this warehouse. We can go through a distribution center then to the warehouse, or direct to the warehouse. You can also get to here from the distribution center to the warehouse, or directly to the warehouse. So these are the ways you can achieve getting what is produced from here to this place at different costs. To get from here to here, you have 700 per unit, whereas from here to here, we have 300 per unit. So you can see there are many ways of achieving what your aim is. But we need to check out what is the minimum, what's the one that will take me lesser money. And there are maximum that you can pick from here to here is 150 units at 400 per unit. So you check what these constraints are and check the best way to do this. So here the circles are the nodes. These circles are known as nodes. F2, F1, DC, they are known as nodes. Whereas the arcs, the lines with arrows are known as the activities, and it could be depicting time or cost. Like you can see, this is cost of doing this. So this lines with arrow can be time or cost. So now, ways of doing network analysis. How do we do network analysis? We can use what we call critical path method. And critical path is the longest route through which you can execute a task, or the most costly route to execute a task. So whenever you hear the word critical, it means the longest or the costliest in terms of cost, longest in terms of time. Now let's take an example. Find the critical path network, then duration or project completion time for the activities in the table. This is the activities. So first of all, you draw these activities into a network, then you determine the one that has the longest path. And to draw these activities is very, very simple. The first one is A, the first activity. I told you that the lines are for the activities, whereas circles are for the nodes. So you can assume node 1, this is the first activity A, and it has duration of 5. That's why we have 5 here. Second activity is B, and it has duration of 4, so you draw. But how do you get to draw from B? You get to B from A, because the predecessor of B is A, so it has to be from where A stops. Next one is C. C also started from A. That's why this is where A stopped. C started from there, and the duration is 3. D from A2, duration is 2. E from B, so E has to be from B. Duration is 8. F from C, so this is F coming from C. Duration 7. H from 8. So you can see G from D. G coming from D, duration 6, and finally H coming from the intercept of E, F, and G. This is where E, F, and G. That's where H started, and duration is 4. So after drawing this now, you can easily determine the critical path. And how do you determine the critical path? You add up the durations. Like if you're taking this path, this from one point to the end point. So you have 5. A is 5. B is 4, E is 8, H is 4. You add it up, you have 21. So what are the other parts? You also have these other parts where you have A to be 5, C to be 3, F to be 7, H to be 4. So if you add up these parts, you see that it's not up to this. This is 5 plus 3, 8, 8 plus 7 is 15, 15 plus 4. 19. So you can see that this is not the critical path because it is not the longest route. This is the longest route. If you check another path, this other path, you have A is what? 5, D is 2, G is 6, H is 4. So you have 5 plus 2, 7, 7 plus 6, 13, 13 plus 4, 17. So we have 17 days. So you see that the 3 parts is either you go from here, there, or you go like this, or you go like this. So the 3 parts, this one is 17, this one is 19. So the longest route is A, B, E, H. So if they tell you to find the critical path network, the critical part of the longest part is A, B, E, H, which is the longest. And the duration, the longest duration of project completion time is 5 plus 4 plus 8 plus 4, which is 21 days. And that solves this problem. So that's how you do critical network analysis using the method known as critical path method. So that is network analysis. In subsequent classes, we are going to be delving more into other methods. Thank you. God bless you. Click on the subscribe button. Like, share our videos.